If you're checking your tire pressure, here's a tip. Go ahead and look inside your driver's door, and there's a panel here that tells you what pressure you should use for your tires. It says cold tire inflation pressure. Now, why should the temperature of the tire make a difference? Let's think about it. It's a cool fall morning, so the tires are cool. But as the day warms up and as the sun shines on the tires, the air inside the tires is going to warm up. And that'll affect not just the temperature, but the pressure. Let's do a problem that deals with that very question. Here's our question. A driver in Colorado, where atmospheric pressure is 12.0 psi, measures the pressure in his tire to be 29.0 psi on a cool 15 degrees Celsius morning. After the tire warms in the sun, the tire gauge shows 32.0 psi. By how much has the temperature of the air in the tires increased? Okay, let's think. We're given atmospheric pressure. And in Colorado, which is about a mile above sea level, where most people live, the atmospheric pressure is 12 psi. Now that's going to be important to us. The initial measurement on the tire was 29 psi. That was at a temperature of 15 degrees Celsius. But as the tire warms up, the pressure rises to 32 psi. Increase in temperature, increase in pressure. And the question asks, by how much has the temperature of the air in the tire increased? We want to know what is the change in temperature of the air in the tires. That's what we're looking for. Now it's pretty clear this is a gas law problem. So we have to think, what type of gas law process is this? We have several different kinds, and we have different equations for each one. What type of gas law problem is this? Think about it. We'll give you some choices. Let's draw the picture this way. The tire is basically a boundary between two regions of space, and there's a different pressure inside the tire and outside the tire. As the air heats up, the pressure inside the tire increases. The pressure in this region is going up because the air is getting warmer. And so there's going to be a larger difference in pressure. But the tire is pretty inflexible. Tires are pretty stiff. So what doesn't change in this problem is the volume of the tire. The volume of the tire is fixed. So this is a constant volume problem. Now, there's a couple of other pieces that we need to look at. We're told that initially the gauge for the tire reads 29 psi, but this is clearly a gauge pressure. Now think about this. The outside pressure is 12.0 psi. That's atmospheric pressure where the tire gauge is being read. So 12.0 psi. That's the atmospheric pressure. That's the pressure outside the tire. The gauge reads 29 psi. And what that means is the actual absolute pressure inside the tire is not 29. It's 12 plus 29, or 41 psi. That's the absolute pressure inside the tire. At the end of the problem, the pressure is increased and the gauge reads 32, and so the new pressure inside the tire at the end of the problem is 12 psi plus the gauge reading of 32, the final pressure, 44.0 psi. And that change in pressure occurs because the temperature changes. And this is a constant volume process. So let's work it out. First piece of the puzzle. We need to convert our pressures from psi into pascals, our SI system. The initial pressure inside the tire, 41 psi. In pascals, that's 283 kilopascals. The final pressure is 44 psi. That is 303 kilopascals. So those are our correct variables. That's what we need. And this change in pressure was due to a change in temperature for some initial temperature. And we know the initial temperature is 15 degrees Celsius. But of course, we have to deal with absolute pressures. We also have to deal with absolute temperatures. And the absolute temperature, we have to add 273 to that. And so the initial temperature is 15 degrees Celsius, but we write it as 288 Kelvin. That's the initial temperature that we want, 288 Kelvin. And what we're looking for in this problem is the final temperature. We want to know how much the temperature changes. So that is the piece that we're looking for. That's what we're going to solve for. To solve this problem, we're just going to use the ideal gas law. And remember, the ideal gas law, PF times VF over TF is equal to PI times VI divided by TI. We can rewrite the equation this way. We're solving for the final temperature. The final temperature is equal to the initial temperature times the ratio of the final pressure to the initial pressure times the ratio of the final volume to the initial volume. But we know that the ratio of the volumes is just equal to 1 because the initial volume is equal to the final volume. So this term goes out of the equation. So in fact, the final temperature is just equal to the initial temperature times the ratio of the pressures. And we have numbers to use for this equation. Let's take the volume term out of the equation and substitute the numbers that we know. The initial temperature, 288 Kelvin. The initial pressure, 283 kilopascals. The final pressure, 303 kilopascals. We have everything we need to solve for the final temperature, and if we do that, we get a final temperature of 308 Kelvin. But what the question asked was, how much did the tire warm up? And so we can do one last calculation, and that's to say this. If we look at the final temperature minus the initial temperature, the final temperature minus the initial temperature is 308 Kelvin minus 288 Kelvin. And so it's 20 degrees Kelvin, or, since differences in temperature are the same in Celsius as Kelvin, 20 degrees Celsius. And so we measure, for the change in temperature of the air in the tire, we measure 20 degrees Celsius, which is exactly what the problem was asking for. Now let's see if that makes sense. In fact, I did check the pressure of my tires first thing this morning, and they were 29 psi. But the car's been sitting in the sun has been shining on the tire's been warming up. And as a consequence, the pressure has in fact gone up. And if I measure it, let's see what we got. The pressure, it's about 32 psi. So I've measured a pressure of about 32 psi. That's a 10% increase from the start of the day. The pressure's gone up quite a bit as the tire has warmed up. That's why you're told to adjust the pressure of your tires when they're cold. You always want to have the same reference because as the air in the tires warm up, so the pressure changes. There's a significant difference over the course of a day. And in fact, the difference in pressure, we measured 29 to 32 psi. The tires are now perceptibly warm to the touch. If I was to guess about how much the temperature increased, I'd guess about 20 degrees Celsius. That's in fact exactly what we calculated. So it seems, it's a somewhat surprising result, but on further inspection, it seems about right. Not too surprising. Physics is about the world around us.